The topic of this video is a combination circuit. And as you can see with this circuit, we have a 5 volt voltage source, which is the battery. Then we have a 5 ohm resistor and a 9 ohm resistor in series with each other. But then those resistors are in parallel with a 10 ohm resistor. So we have a series circuit and a parallel circuit. This is why it's called a combination circuit. Okay, so the 5 values that we're going to determine for this circuit are 1. The total voltage of the circuit, 2. The total resistance of the circuit, 3. The total current through the circuit, 4. The current through each resistor, and 5. The voltage drop across each resistor. Okay, so I made a little sketch of the diagram in the top right hand corner. So the first thing that we need to find is the total voltage of the circuit. So the voltage is just V equals 5 volts. So that is the total voltage. So I'll make a note of that here. So I say VT equals 5 volts. Okay, so I now need to find the total resistance of the circuit, or the equivalent resistance of the circuit. Now the first part that I'm going to do is the resistances that are connected in series. So I have a 5 and a 9 ohm resistance in series. So for a series resistance, I'll call that RS. That equals R1 plus R2. So RS equals, and we have 5 ohms for R1 and 9 ohms for R2. Therefore RS equals 14 ohms. So now I have the value of RS. I can see that I've got a 10 ohm resistor in parallel with that. So I can use the product over sum rule. So the product over sum states that we have RS times R3 divided by RS plus R3, and this equals RS is 14 and R3 is 10. Divide that by RS plus R3, and that is 14 plus 10. So this gives me 140 divided by 24, and that equals 5.83 ohms. So the total resistance of the circuit, RT, is equal to 5.83 ohms. So I'll make a note of that up here. RT equals 5.83 ohms. Right, so now I've found the total voltage and the total resistance, I can calculate the total current through the circuit using Ohm's law. So IT is equal to VT divided by RT. Now I've already got these values, so that equals 5 volts divided by 5.83 ohms, and that equals 0.86 amps. So I'll make a note of that at the top. IT equals 0.86 amps. Okay, so now I've found the total current. I need to find the current through each resistor. Well, we know that there's 5 volts across these resistors, and we also know that RS, the series circuit, is equal to 14 ohms. So the same current flows through R1 and R2. So we could just use the total resistance for that. So RS, we'll say for the series circuit, so that equals 14 ohms, as we previously calculated. So to find the current, we say that I equals V over R, but this time it's RS, and we know that V is 5 volts, so I equals 5 divided by RS, which is 14, and that equals 0.36 amps. Now we need to find the current through the 10 ohm resistor. So again, using this calculation, Ohm's law, I equals V over R3 this time. So again, the voltage is 5 volts. Divide that by 10, and that equals 0.5 amp. Now, by this time you should know the rule that the total current, IT, equals, and we'll say that this is IS for series, and that can be I R3. So the total current equals IS plus I R3, which equals 0.36 plus 0.5, and if we add those together we get 0.86 amps. Okay, so I made a note of those values at the top. Now I need to find the value of the voltage drop across each resistor, and to do this I'm going to use Ohm's law. So V equals I times R. So for V3 we know that there's 5 volts across it, so V3 is just going to equal VT, which equals 5 volts. For O1, yeah, we can say that V1 is equal to I1, and we know that I1 is the current flowing through that series circuit, which is 0.36 amps. Multiply that by the resistance of O1, which is 5 ohms, and that equals 1.8 volts. So again, for O2 we say that V2 equals I2, which is the same current flowing through I1, so that's IS, which is 0.36 amps. Again, this is times the value of O2, so that's 9 ohms, so that's 9 ohms, and this equals 3.2 volts. Now, just as a check, VT should equal V1 and V2. So VT equals V1 plus V2, which equals, and we'll add these two together, so that gives us 8, 10, that's 1, 4, and 1 is 5, so that gives us 5 volts. So that is correct. So just to recap, first of all we found the total voltage, then we found the equivalent resistance of the circuit, then we found the total current flowing through the circuit. We then found the current flowing through each branch of the circuit. Then that allowed us to find the voltage drop across each resistor.